Hey guys, this is topic 5, energy and earth processes. This is a precursor to the weather chapter and climate chapters that are coming up. It's basically a foundation chapter along with the next one, which also will be a little bit about energy, but energy from the sun. But this will be energy in general, right, that we're going to be talking about in this chapter. So energy is the ability to do work. You're going to say, what does that mean? Well, work is a force over a distance. So we just see how much force is applied on an object and whether or not it moves, and that's how we measure the amount of energy in an object. What you guys really need to know, though, are where does the energy come from in the earth? So externally, we have the sun, and then internally, we have the radioactive material in the center of the earth. Remember, the earth is very hot in the middle, and it's because of that radioactivity and that material that's molten. Electromagnetic energy is defined as anything that is energy that is given off in terms of waves or in waves. And this energy is given off in anything that is above what's called absolute zero. Absolute zero is the theoretical lowest temperature possible. That would mean that molecules are not moving at all in objects. They're not wiggling, they're not moving at all. So that's negative 273 degrees Celsius or 0 Kelvin, which is a special scale that is made for absolute zero. Review of waves, we did talk about these when we talked about topic 3. So just a reminder, so crests are the tops of the waves, troughs are the bottom of the waves, and the distance from crest to crest or trough to trough on a wave is called a wavelength. So that's how we measure waves. We see how long they are, and we see how often they are hitting us. We call that frequency. So an object that is vibrating slowly is a longer wavelength, that is less energy being released. Whereas an object that is vibrating rapidly is giving off a tremendous amount of energy, so therefore it has a shorter wavelength, which will hit you more frequently. And that's why I mentioned earlier that when we talked about this, shorter forms of wavelengths are actually more dangerous than longer forms of wavelength long term. So an example of that, this chart on the reference table. So gamma rays, X-rays, ultraviolet are all short wavelength radiations. Okay, actually pretty dangerous stuff there. Usually cancer causing, especially if you're exposed to a lot of them. And that's why when you get X-rays, you get that big lead suit over the top of you, right, to block some of them from going into your body. Ultraviolet, you have to wear sunblock to be out in the sun for long periods of time. Okay, and then the middle, don't forget, visible light is a small little portion right here in the middle. And remember, that's made of the colors of the rainbow, Roy G. Biv. And you know that violet is a shorter wavelength, red is a longer wavelength. So it does follow that also with longer and shorter. Infrared, microwaves, and radio waves are all longer wavelength radiation. Okay, and obviously these are used in regular life. Infrared is heat. Microwaves we know we use for cooking. And of course, radio waves we know we use for wireless signals, radio, TV, all those signals are radio waves. So we constantly have those bouncing around because we all have wireless internet in our houses that we use. Okay, electromagnetic energy has to interact with the environment sometimes. So these waves that are going through your house or moving through the sky, whatever, or through space, they will sometimes interact with things. So refracted means it bends, all right, or changes direction. I'll show you an example of that in a moment. Reflected means it bounces right off. So occasionally certain energies are bounced off walls, as an example, or the ground. Scattered means it actually refracts or reflects in various directions. And then transmit means it passes through, which you hope your wireless signal does that. It transmits through walls. But again, over time, if it goes through many walls, it will stop transmitting. Instead, it will be absorbed or taken into the wall. Okay, so absorbed means it does not pass through anymore. So transmitted means to pass through, absorb means to take into. All right, and here's an example of a reflection with the zebra. You can see it in the ground here, or the water that's underneath him. And then refracted, here it is. So here the pencil looks bent, but it really isn't. The reason why it does that is the light waves are going into the water, and they change direction when they go from air to water. So it appears that the pencil is bent, but it really isn't. And that becomes like an optical illusion, as people would call it. But it's really just the light waves slowing down as they enter a different medium, or in this case, from air to water. Here scattered, so you can see energy being scattered in the solar system. All right, right here we also have other examples of this. So transmission means to pass through, reflection means to bounce off of, diffusion or scattering is every direction, you can see. Absorption means to take into, and a lot of times if energy is absorbed, the object will heat up. All right, and that's one of the results of that. And then emission, that's something we didn't talk about. We can also call it a radiator. They give off energy. So objects that obviously take in energy will also emit or radiate it out. And we're going to use that next chapter big time. Okay, so absorption of surface properties. Okay, so a good absorber, a poor reflector. So that's objects that are dark colored and rough. Right, and I'll give examples of that in a moment. Poor absorber, good reflector are going to be light colored and smooth. Perfect example of this. That's why we wear light colors actually in the summer. Light colors in the summer will actually keep you cooler outside, right? Because you won't take in the sunlight as much. That's why white is a good color to wear during the summertime. Whereas a black colored shirt, you will feel much warmer, right? Because you're absorbing all the sunlight. So good example in real life. And also that might be a factor in your car interior in the future. So remember that when you're buying your car. If you get a black leather interior, it is very hot in the summertime. All right, so good absorbers could include anything that is dark colored and rough. So brick, asphalt, dirt, green ocean water, forest, black materials, black car interiors. So I mentioned that as an example in real life. Anything that is dark and rough is a good absorber, poor reflector of energy. So it all takes in the energy well. Whereas an example opposite of that is a poor absorber or a good reflector, snow. All right, that's why we have to wear sunglasses when we go skiing. A calm lake, a mirror, white materials, aluminum, white car. All right, anything that's smooth and light colored will actually be a poor absorber or good reflector of light. Okay, another thing to add to this whole factor, something that absorbs energy well will also give off energy well. That's why pavement during the summertime, you'll feel the heat coming off of the pavement because it's absorbing the energy really well, and it will also give off the energy well. So we call it a good radiator of energy. So asphalt heats up quickly and also cools down quickly as a result. That's why during the day it's super hot, and that's why during the nighttime it actually gets pretty cold. All right, other energy things you need to know are energy transfer methods. Okay, so conduction, that's a transfer of heat energy from atom to atom or molecule to molecule. So it's energy transfer within the substance. This is effective in solid materials because the materials, the particles are actually really close together in them. So metals tend to be very good at this because atoms are really close together. So an example, a hot poker in a fire, okay, that will take in the energy, and the energy will go up the hot poker towards your hand. That's why you'd want to wear a glove. Same thing with a pot on the stove. The handle, if it's not an insulated handle, the handle will actually get pretty hot. And then here's the classic example they like to talk about in questions. Here's a metal bar connecting two styrofoam cups with water. One's hot, one's cold. the energy will transfer across the metal bar to the colder cup from the warm cup. And that also is an example of conduction. Okay, convection, you guys already know this from previous chapters. So heat transfer by movement in gases and liquids, any fluids, due to differences in density. So warm air rises because it is less dense. Cold air sinks because it is more dense. And you get a circulation pattern called a convection current because of this. This is the big driver of weather. That's why I mention it again. Because clouds will form as air rises and then sinks. It will actually dry out the air. So that's how we create weather, and we're going to get to that more in the future chapters. But that's also how heat disperses in your room or your fish tank, as an example, or your pool outside. The deep end versus the shallow end of the pool, you see a big difference. The deep end tends to be very cold on the bottom compared to the surface water in the shallow end. And that's all due to convection. So warm water rising, cold water sinking. And lastly, radiation. So we already mentioned this term, but it's a heat transfer by electromagnetic energy or waves. And no medium is needed. What does that mean? This type of energy transfer can happen in outer space. So can travel through solid, liquid, gas, and outer space. And that's how our sun's energy gets to us, because it is a form of radiation. All right, and that's it for this set of the notes. Just keep working along, guys, and I'll talk to you soon.